Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. And it's me, Richard, here. Yeah, tonight we are looking at this question. It says that write the general formula of alkynes. Okay. So what's the general formula of alkynes? It is CN H2N minus 2. So comes the next question. It says, state whether alkynes are saturated or unsaturated and explain your answers. Okay, first of all, what are they? They are unsaturated. Why do we say so? Okay, answer is that they possess a triple bond, which is a multiple bond. So that is that they possess a triple bond between carbon atoms. So comes this question. It says, write the structure formula and the name of the functional group of alkynes. Okay, what is the structure formula of the functional group? Alkynes have a triple bond between carbon atoms. So you have a carbon atom with a triple bond between them. So from here, you have to know that each carbon must exercise a covariance of 4. So each one has 3 already. So you have to show one attachment and one attachment. So this is the structure of the functional group of alkynes. And what is the name? The name is triple bond. Between carbon atoms. Yeah, then comes this question. It says, the molecular formula below is of an alkyne. Okay, identify why. Okay, if this formula is of an alkyne, then what is Y? We need to remember that alkynes conform to the general formula CN H2N minus 2. So when you come to this one, what are you going to say? It's going to be C5 H2 times 5 minus 2. What do you get out of this? You're going to get C5H. 10 minus 2 is 8. So Y is 8. So then comes this question. It says, write all the possible isomers of that and write the UPAC name of each. Okay. So what do we have here? We have 5 carbon atoms. So the first one is going to be C, 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 C. Those are 5. And an assumption that we have our triple bond here. So how many are missing here? 1, because it has already 3. How many are missing on this carbon atom? None. It has the 3 and 1, which is 4. How many are missing here? 2 and 2 and 3. So what is the UPAC name? The UPAC name is going to be 1, 1, 2, 3. It's going to be 1, 2, 3, 4, 5. It's 1 pentine. We have to remember that the functional group, which is the triple bond in this case, must be given the smallest number. Okay, we can also call it pent 1 ine. Okay. Then the next alternative is going to be C, 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 C. Those are 5 with a triple bond here. So in this case, let us identify the number of bonds here. There are 3 because it has 1. For this one, it's not missing any. It has 4. It has 1 and 3. Even this one, it has a 3 and 1. This one has 2 and this one has 3. And what is going to be the name? The name is 2-pentine or pent 2-ine. Then the next one, then we can have this 1, 2, 3, 4. Suppose we have a branch here which makes it number 5. Then we can identify the bonds. But first of all, you have to remember that we are dealing with alkyne, so if you have a triple bond here, let us identify the number of bonds missing. This one has 1, it's missing 3. This one has 1, 2, 3, it's missing 1. This one has 3 and 1, it's not missing anything. This one is missing 1. Okay, so that's what we are having. All the outlets are hydrogen atoms. What is the UPAC name of this? You have to recall that our triple bond must be given the smallest number. So in this case, even here, we took this side because it was giving us 1, 2, 3, 4, and 5. It was giving us, we give the functional group the smallest number. In this case, we are having this one as number 1, number 2, number 3, number 4. Because of that functional group, it has to be given the smallest number. I emphasize that. So in this case, what are we going to have? We are going to have 3 methyl, 1 butane, because there are 4. Or we can say 3 methyl but 1 ine. Okay, after that, you have to know something, that if you put a triple bond here, it cannot work. Why? Because this carbon atom has already 2 bonds. So if you add 3 bonds here, there will be 5, so it cannot work. The same applies to this position. It cannot take up a triple bond. Why? Because if it takes a triple bond, this carbon atom will have 5 because it has already 2. So this is our last compound. But we have to also remember that these two, they are position isomers. They have the same functional group at different position on the same parent chain. And with that, would want to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. Don't forget to subscribe. Don't forget to like, to share. We are simply the best. Bye-bye.